Alright, these are the notes for interval notation and set builder notation. So the first thing it says is to write the inequality expressed on each number line. So if you can recall how to write inequality notation, that's going to be a good start. So first off, start with x. And I can see that 2 is smaller than the biggest number, so 2 is less than or equal to x, or you could say x is greater than or equal, greater than 2. Another way you can write it is 2 is less than x. So those mean the exact same thing. Now you have a one that's bounded here. So starting at your smallest number from the left, we always read the number line from left to right. So right here we can see it's a closed circle at -3. And our largest number is x in the middle, and our largest number is 5. Okay, so for here I can see that -3, and I consider this dark line to be x, so -3 is going to be less than or equal to, since it's a closed circle, x, and x is less than 5, no equal bar because it's an open circle. And then for the last one, this is x, which is less than or equal to, and this is -3. And since it's not together, we use the word or when it's a compound inequality. X is greater than 1 and not equal to it because it's an open circle. So hopefully you can recall that from Algebra 1 there. And now we're going to get into set builder notation, and set builder notation is actually very similar to inequality notation. So here, let's talk about a couple things you probably need to know. Let's see. First off, a set or a list must be written within braces. So if you have a set or list of numbers or list of whatever, it's supposed to be in braces. And symbols that you probably should be familiar with, this is all real numbers. This little E right here, it means is an element of. And this little line right here is going to mean such that, and we'll get to that in a sec. Alright, so set builder notation. Let me give you one more example and then we'll start talking about this here. We could have something like this, where it says x is an element of all real numbers such that x is greater than 5. So that's one way to write set builder notation. We usually shrink it down a little bit. Is an element of. We don't use x is an element of all real numbers. We just say braces x such that x is greater than 5. And both are going to be acceptable. So finally, let's go ahead and start. It says set builder notation. So let's go ahead and fill this in now. So set builder notation uses symbols to define a set in terms of the properties of the members of the set. So we read it as the set of all real numbers x such that x is less than b. And really, you're going to hear me say the set of all real numbers x such that x is less than b. Okay, so yeah, that's pretty much what you need to know for set builder. So the difference between your inequality notation and your set builder is we have the introduction of the braces, x such that, and everything else is pretty much inequality notation. Okay, so take a look at this right here. We have two graphs right here. Let's kind of talk about how you can write those. So for here, we can say braces x is a set of all real numbers such that x is less than or equal to a, or since it's broken apart, x is greater than b, and no equal bar because that's an open circle. And for the second one, braces x such that. Now here we can see x is actually the whole number line except for that a because there's an open circle there. So I can say that x does not equal a. Or I could say x is less than a, or x is greater than a, but just a cannot be included. All right, and now let's get to these examples for set builder. So it says, sketch the graph of each set of numbers. Okay, so x such that 2 is less than x, which x is less than or equal to 5. So first off, I'm going to plot these numbers on the number line. So here is, let's say, put a 2 right here, 3, 4, 5. All right, and now we can see we have an open circle on 2, and 5 we have a closed circle because it is equal to. And since it's a between statement here, we're just going to connect these two dots, and there's the graph. All right, for letter B, x such that x is less than or equal to 0, or x is greater than 4. So once again, we're going to plot our numbers. So let's put a 0 here, 1, 2, 3, 4, 5, 6, negative 1, negative 2. So above 0, we're going to put an open circle, and then we're going to fill it in because it's equal to it. And then above 4, we're going to put an open circle, and we're not going to fill it in because it's greater than. Now, usually when it's written like this, as long as x is on the left side, the arrow pretty much tells me where to go. Or if I just read the inequality symbol and understand it, it's a lot better that way. So x is less than or equal to 0. So here's a number line. All the numbers less than 0 go to the left. And or x is greater than 4. So all the numbers greater than 4, 5, 6, 7, 8, 9 to infinity are to the right. And there's my graph. All right, these right here say write each interval in set builder notation. So for this here, start with our braces. The set of all real numbers x such that, and here remember I say this is x, and I can see that x is greater than that 2, so I can write x is greater than 2. There's no equal bar because it's an open circle. For the next one, this one, compound inequality, it's between, it's together. So braces, x such that. So whenever you have this here, you can just put the smaller number first. You know that x is in the middle and the bigger number last. And then from here, use your knowledge of inequality. So I know that x is greater than or equal to negative 3 because it's a closed circle and x is bigger. But at the same time, x is less than 5. And for the last one, we have that split x such that here, I use this inequality here, I can see that x is less than or equal to negative 3. Or on this one here, I can see x is actually greater than 1. And once again, open circle, no equal bar, closed circle, equal bar. All right, next thing, we have bounded intervals on the real number line. So it says let a and b be two real numbers such that a is less than b. Then a and b are the endpoints of 4 different bounded intervals. On the real number line as shown below. So a bracket or closed circle indicates the endpoint is included in the interval. So brackets would be, those are brackets and closed circle. Whereas a parentheses or open circle indicates that the endpoint is not included in the interval. So parentheses and open circle. Oh, sorry, let's bring that there so you can see better. So there are my brackets with the closed circle, parentheses with open circle. Now, these can be mixed together. It doesn't have to be bracket, bracket. It can be bracket, parentheses, or parentheses, bracket, however it's going to be set up. Now, this right here is just a table to kind of show you the different ones that could possibly be. So a is less than or equal to x, which is less than or equal to b. We see that graph right here. So the way we write that in interval notation, we don't have to worry about x or y. We just put the number smallest first to largest, and since they're both closed circles, that's why there's brackets. The second example, once again, smallest number is a, largest number is b, no closed circle, so both use parentheses, and here's where they're kind of using both of them. So a is the smallest again, b is the largest number, bracket because that's closed, parentheses because that's open, and the last one, a is smaller, b is larger, open parentheses on a because it's an open circle, and bracket on b because it's a closed circle. So when you are doing this interval notation, make sure when you do it, it's small number first to larger number second. So it's kind of like reading a book or reading a number line, always left to right, smallest to largest. And then we get to our unbounded intervals on the real number line. So let a and b be real numbers. Each interval on the real number line shown below is called an unbounded interval. And it's unbounded because you have a arrowhead that goes either to positive or negative infinity. So here, once again, if you look at here, it's a is a smaller number, and this heads towards positive infinity because it's going to the right, so infinity is the bigger number. Closed circle, so that's bracket. One thing that's very important, infinities will always have parentheses. So infinity, positive or negative, always use parentheses. So negative infinity should have parentheses, just like positive infinity. So over here, you notice infinity does have a parentheses. Here, a is still smaller, and this heads towards infinity, so that's why it's from left to right, smallest to largest. This is an open circle, that's why there's a parentheses. Infinity always has a parentheses. Over here, you can see the graphs going to the left, which on a number line that heads towards negative infinity, that's why that number's smallest first. And b is on the right side, which means it's bigger. B has a closed circle, that's why there's a bracket. Negative infinity always uses a parentheses. Once again, over here, same example, except b now has an open circle, so we use a parentheses. And remember, negative infinity is smaller than b, because b is furthest right. And this one right here, this heads towards negative infinity, this heads towards positive infinity. Notice they both have parentheses because we don't actually have a value for that. There's two ways to write this. First, you can actually write out words, all real numbers. And I like to use that symbol. It's two lines and the R going through it for all real numbers. All right, now the last one says write each interval in interval notation. So once again, when you're doing this, start reading it from left to right. So from left, I see there's a 2 there. That's my smallest number. Then as I continue on, I see an arrow, and you got to be careful because you got to remember that arrows head towards either positive or negative infinity. Numbers are getting bigger, so that's infinity. Open circle, parentheses, infinity, parentheses. All right, for the next one, as I start from the left, first closed circle is at -3. And as I continue, it ends at 5 right here. So -3 has a closed circle, so that is a bracket. Open circle on 5, that is a parentheses. And then for the last example here, as I start from the left, I automatically see an arrowhead, and I know that this arrowhead on number line heads towards negative infinity, comma. As I continue, there's a closed circle at -3, and then there's a space between the two. So when you're doing inequality or set builder, you use the word or. When you're doing interval notation, you use the letter U for union. And then as I continue on, it starts up again at 1. And then I go to the very end, and I see an arrowhead, which I know the arrowhead goes towards positive infinity. Now I'm just going to go back and put my parentheses or brackets as necessary. So negative infinity always has a parentheses. -3 has a closed circle, so that's going to be a bracket. Union. 1 has an open circle, so that's a parentheses. And infinity approaches infinity, so I use a parentheses. All right, moving on. So now we're going to get to increasing, decreasing, and constant. So with this here, this stuff is a little bit, it's not challenging. I think it's not bad, but you've got to be careful because people make small errors here, and try not to get caught with those. So let's take a look here. All right, so a constant line. So if you can recall what a constant line looks like, it's a horizontal line. It looks something like this. So y equals some number. Okay, so as the x values increase, the y values do not change. Okay, they stay the same. And from left to right, the graph remains constant. Okay, so that's pretty much it. I can't really say anything else about that. It just remains constant. All right, now for increasing. For increasing from left to right, our graph rises. So we can see from left to right, the graph is going up. So as the x values increase, the y values also increase. And from left to right, the graph rises up. Now for decreasing, so as the x values increase, the y values decrease. And what that would look like is the graph from left to right will be going down. Okay, so constant is horizontal, remains the same. Increasing from left to right goes up, it increases. And decreasing from left to right goes down. Okay, so that's pretty much constant, increasing, decreasing. Okay, so last we have positive and negative. Now, the reason why people struggle with this sometimes is because they get these two concepts mixed up together. So increasing and decreasing and constant deal with the actual function, whereas positive and negative deal with the value or the graph where it falls above or below the x-axis. Okay, so let's kind of go through this. So positive, as the x values increase, the y values are always positive. So let me show you what that looks like. So here's a graph, or sorry, here's the x-axis. Okay. Every part of the graph that is above the x-axis would be considered positive. So anything above this black line, the x-axis, is considered positive. Whereas if we get to the negative, as the x values increase, the y values are always negative. So once again, we draw the x-axis. And here it is. And where the graph is always going to be negative is below the x-axis. Okay. Now, the x-axis itself, we would consider that to be 0, which would be neutral. So it's neither positive nor negative. It's just not included in either one. Now, when I look at all of this here, every single interval I'm asking you for will always be reflected from some point that's on the x-axis. Okay, so let's kind of go through this so you can see what I mean. All right, so right here, on what intervals of x is f of x constant? So when I look at this here, where is this graph constant? Well, I see from here to here, it is constant, okay? And I'm going to relate that to the x-axis here and the x-axis here, which is an arrowhead, okay? So for constant, it's going to be from 1, 2, 3, so that starts at 3. And as I continue on, oh, it's not an arrow, it actually stops right there. So let's, you know what, let's put some arrows on here. Let's put 1 right here, and let's put 1 right there. Yeah, that's good. Actually, you know what, let's make this a closed circle. Because we can talk about that. I'll make this one a closed one. Okay, so it starts right here at 3, and we know that arrowheads head towards positive infinity. Now for here, let's talk about when to use brackets, okay? So right now we know that this goes towards infinity, which is automatically a parentheses, okay? So I'm going to write a note here. Only use brackets when there is a starting point or ending point of the function that has a closed circle. Okay, so that's when I expect for you to use brackets. Only use brackets when there is a starting point or ending point of the function that has a closed circle. So right here, this is a closed circle, and that is an arrowhead. So the only one that actually has a starting point is right here. There is actually no end point because we know that goes towards positive infinity. So this right here is when I would use a bracket. Everywhere else, just use a parentheses, and that would be fine. So there's my print. So it starts at 3, and it goes towards infinity. All right, on what intervals of x is f of x decreasing? So decreasing, so it's going to be from here down to there, okay? So we'll relate this to the x-axis again, so starting here and stopping here. So it starts at -1, -2, -3. Oh, sorry, I'm doing increasing, I'm doing decreasing, I'm sorry. So it's decreasing from -3, and it stops decreasing down here at this, but when we go up to the x-axis, it's 1, 2, 3. So it decreases from -3 to 3 in terms of the x-axis, and since there's neither a starting or ending point for this, because it's not the beginning of it or the end of it, we just use parentheses. All right, let's go back to this one. On what intervals of x is f of x increasing? So where is this graph rising? Well, it's rising from here all the way to there. So that's a closed circle at this point here, and it ends right there. Now, since this is a starting point and there's a bracket, or sorry, closed circle, we are going to use a bracket there. So -3, -4, -5, -6, -7, -8, -9. And it stops increasing at the x value of -3. Starting point with a closed circle, that's a bracket. This is an ending point, but it's not the end of a graph, so we just use a parentheses. Okay, now this is where people start making mistakes. You have to be careful here, okay? So now, on what intervals of x is f of x positive? This does not mean where does the graph increase. What this means is where is this function above the x-axis. So where is this graph above the x-axis? So for me, I can see that from right here, it is above the x-axis, above, until I get right here, it is no longer above. It is on the x-axis. So from here to here, it is above the x-axis. So if I count these intervals, it's -1, -2, -3, -4, -5, -6, about -6.5, comma, and that's 1, let's say that's 1.5. Now, are those numbers included in terms of being positive above the x-axis? And the answer is no, because this point right here falls on the x-axis, which we talked about being neutral, so it's not a part of positive or negative, and 1.5 for x also does the same thing. So to show that these intervals are not included in our solution, we use parentheses to represent that it's not a part of the solution set. Okay. Now last, on what intervals of x is f of x negative? So once again, when we say negative, we don't mean where is the graph going down, where is it decreasing. We mean where is this function below the x-axis. So where is this graph below the x-axis? So once again, it's those same points that we used before, but this time when we talk about where is it below, well, it starts from right here, and it stops at that point there, because then it goes above, and at this point it's 0 or neutral, and then it goes below, which is negative, 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 negative. Okay? So here we start at this value here, which is -9. And since it's a closed circle, I do use a bracket. It's negative, 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 negative until that point there, which we figured out was -6.5. Parentheses, because it's on the x-axis, which is neutral, so we don't include it. That's positive, 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 positive. At this point, it is neutral again. So union 1.5, we said it's not included because it's on the x-axis. And then from here on, it's negative, 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 all the way till positive infinity. All right, last but not least, we have these things right here, f of 0, f of negative 3, and f of 5. So let's kind of talk about function notation really quickly. So we remember, or we should recall, that f of x is equal to y. Okay, so that's function notation there. So pretty much what we're giving you here is, if I give you a number here, like let's use this f of negative 3, I'm telling you that x is negative 3. What I'm asking you actually to find is the corresponding y value. So how would I do this problem? So here's my graph. I'm going to go to where x is negative 3, so negative 1, 2, 3. Then the first thing I do is go down to see if I hit my function, which I don't. Then I go back up, and when I go back up, I see I hit right here at this point. And then the corresponding y value here is at that point right there. So I'm going to count it, 1, 2, 3, 4, 5, 6. So f of negative 3 is equal to 6, and pretty much what that makes is a ordered pair, right? That's negative 3 comma 6, so negative 3 comma 6 is where that point is that we talked about. All right, so if I did f of 0, so once again, I'm telling you that x is 0. So I always go down first to see if I hit the function, which I don't. Then I go back up, and I see I hit it right there, and that y value right there is positive 2. So I can say that f of 0 equals 2. And just like I said before, ordered pairwise, that's 0, comma 2. So x is 0, y is 2. But the answer I'm looking for is just right there, 2. So for f of 5, last one. So here I count it, 1, 2, 3, 4, 5. So here's the x value of 5. So I go down, and I notice I hit my graph right away right there. And I don't hit any other points. I go up, I hit nowhere else. So it's right here. So I go to the y-axis, and I get the y value. So that's negative 1, negative 2. So f of 5 is negative 2. And that's going to conclude the notes for interval notation.